Welcome to the stage, Ellen Sundh.
Thank you. Yes, so I'm here to talk about haptic feedback and the power of touch. And I'm running my own company, and I'm a developer who got into electronics about 10 years ago, and I often connect them to internet. But today I'm going to talk about specifically actuators that I used in haptic feedback. Because about a year ago I got the assignment to help Wu Ying here. She's a blind musician, and her dream is to play with an orchestra, within the orchestra. Because often when she plays, she's actually a solo artist, because the orchestra, they need to follow her all the time, because she can obviously not see the conductor. So I thought maybe technology could help this. How could she actually feel the movements of a conductor? And has she even felt the movements of a conductor? Does she even know the movements? I mean, we assumed in the beginning of this project that everyone knew, but at the first test, we see here the conductor Andreas. He's basically conducting with his finger on her back, and he feels that he actually has control. He knows that she's actually following the pace and the tempo and the beat. So that was kind of the first thing to actually have some kind of connection. And when you conduct, you basically move your hand in different directions. So the first beat is in a certain direction and the second in another, and so on. And I thought, as I've been working with a lot of different hardware, I started to think about what if I could just use a Kinect. And I started off with a Kinect 2 to actually sense both my hands. And I thought this would be interesting to actually get the expression as well, because obviously the expression of the conductor is really important, and the look. And you could do that with the latest SDK for Kinect as well. So I started off that I wanted to get all the signals in from the conductor. And what you see here is basically Wu Ying, she has a belt with vibration motors. And that was one of the first tests to actually take the conducting hand, one of them, and just move them side by side in sideways. And these different vibration motors would then move in different ways. And it was quite magical, because it kind of worked. And I thought, I'm probably one of the few people that actually conducts a blind person right now. Yeah, that was amazing. But I'm doing it with about 2 seconds delay. And from what I learned, I'm not a musician myself, timing is of essence, obviously. And if you think about all the people in an orchestra, they use their eyes to see the conductor, and that's the slowest sense we have. The Kinect camera is also using a lot of information in the camera to sense that. But I continued, and I actually wanted her to try this vibration belt on different parts of the body. And in this case, she actually put it on her neck, because she felt that she had a better response and sense in the neck. And in the previous one, she actually uses her fingers to feel more. And if you look at the body, we actually have different resolutions. We could say that on the fingertips we have like retina display. It's really good. And hence many blind people use Braille to feel the Braille language. And you can see here that the tongue has the best resolution. And in this case, the back is really bad. And so I thought maybe the tongue, but no. But there have been really interesting examples of that, like BrainPort. It actually has a grid of 400 electrodes placed on the tongue. And since the tongue is has humidity, it always has connection. And it's connected to a camera that basically takes the camera image and makes it into contrast of black and white dots. And the black dots tickles on the tongue. And this has been used for people who have been seeing and then they got blind, and they actually can write letters, they can climb because they see the contrast or feel it. And it's this notion that you can actually connect a new sense and rewire the brain, so the things you feel on the tongue basically replaces the visual cortex in this case. And so I thought maybe I should have just a TENS machine, and I put that on her back. But I also realized with tests that if you put these electrodes on the back, muscles will jump. And depending on where you put them, you basically get a very uncomfortable situation for a musician in an orchestra. I also looked around at some other things, like from the university in Bristol, they used a pattern of ultrasonic speakers. And by moving air in a certain direction, they can concentrate air, so you actually can feel things just in the space. It feels like you're holding something. But it works on 2 decimeters. And I haven't tried it myself, but I have a friend who tried it, and he said it was a tickling feeling. And I think this is also an interesting way to feel stuff. And in this case, it was combined with a leap motion as well. So you can actually take something that feels like a ball and move it in air. But yeah, this was, I mean, it's so early on, so I can't use that. And I also thought that if you would use that through fabric, would that work? And would this be in a chair and she would be leaning forward at this perfect distance? No. I tried speakers as well. So I thought with putting a certain frequency, the speaker wouldn't actually sound but just move. But that was also a very subtle feeling, and I wanted it to feel a lot. And while I was exploring this, I also explored these different vibration motors, some bigger and some smaller, and I put them into different patterns because I wanted to see if I could actually get the hand movement from one hand. And I mean, vibration motors, they've been used a lot in different things, and they are used a lot for blind people. And for me, I used just a breakout board from Adafruit to just send PWM to all the different motors and basically turning them on and off. I tried an H-bridge, so you basically turn on the motor and then you break it to the other end, so you actually get a really, larger effect, because you're actually breaking it really fast in the other direction. And it's been used in many different things. I mean, like real big vibration motors are in gaming, handheld things like this, or the most common one in the mobile phone. Some use it now, connecting it with VR, so you basically can feel stuff. And as you see, it's on the hands, because that's the best way to feel things. And by actually starting them and then breaking them, it actually feels like you're touching something that's not there. In the US Army, they try this as a belt. So you always see or feel true north on the belt. So if you go in somewhere and it's totally dark, you have a reference all the time. And it's a vibration motor that changes place. And it's also really if you're in a shoot 'em up game, or if you're driving a car in a car game. So I was still holding on to the vibrations and motors, but I wanted to change the input. And I'm here to talk about actuators, so I'll just tell you briefly about this. I looked at different sensor boards, like the light blue bean, the sensor tag, and the Swedish automat. This one had an accelerometer, and the other one said gyroscope and some more. And I could actually tell the pace. And at this point I thought, I should just focus on the pace and the beat. I'll leave the expressions and stuff. First of all, my goal is that she will start when everyone else will start in the orchestra. So I tried this on, and I basically had a 3D printed, it's not showing very much here, but I had a 3D printed model, a holder for that sensor board. And basically, depending on where I moved it, different motors would start. And this was exciting because I read some papers that you can actually create more movements with less motors. And this is just a graphic taken from one of those papers. So if you have two motors and you start one and give it full speed, and the other one is just 0, and then you slowly bring down the one that's on 100%, and you start the other one and you bring it up to 50 and it goes up to 100 and the other one goes down to 0. If you have this on the skin, it actually feels like something is moving. So the skin interpolates these two movements. And here is graphics on how to interpolate these. So this one is full speed, and then it's less and less. And in this way, you would actually feel that something goes down, or it moves, and it turns. And these have been used in gaming chairs. So basically, if you get hit in a car racing game, you would feel a movement in one direction. So they are used, but I tried it myself, and it took a while to actually get the feel of it. And at the same time, I was thinking about timing. I don't have the time to sense this. But we did a test with Wu Jing. It's hard to see her now, but she's sitting here. And I have a belt with vibration motors on the back, a Raspberry Pi that receives a signal from a circuit with sensors. And we actually realized that after a while, the skin, it vibrates by its own. It's almost like it kind of tries to feel for more movements. It's really hard to feel a certain vibration when you have been having vibration motors on you for a while. So I tried some other actuators, and I thought maybe I could actually take a sensor board, connect it to an iPhone, and make it into sound and use this product, which is actually used for DJs. So when they are DJing, they want to just know the next song and feel the beat of it. And this turns music into vibration. It's some vibration motors within there that actually are really subtle and actually in an instant just converts the sound into vibrations. And I tried this on her teacher, who's also playing the flute, and he thought that, yeah, I get the sense of the pace. That should really work. But I noticed also that it's not just the pace, but I actually have to know which beat. So the first one in a conductor's job is to actually just show which one is the first beat, and that's always this one, and then the second, the third, and the fourth. And in this case, you couldn't really differentiate the different kind of beats. So I went on, and I started to look at these new actuators, linear resonant actuators, which is basically a new kind of haptic feedback that we now can see in other things, like, for instance, the Apple Watch. And instead of having a weight that vibrates or rotates, it actually has a spring and a weight, and with magnetic force it just goes up and down, and you can get a sense of something tapping or knocking. And that's the same thing that you can see is called a Haptic engine in an Apple Watch. And these weren't available at that time, so I thought, I'll just buy an Apple Watch then. And I connected the sensor board to an iPhone, and then I got the beat in the Apple Watch. Unfortunately, the Apple Watch processed every signal, so it took a while. and it buffered all the signals as well. So I was stuck, and I thought, I have to think through all of this again. And also I need to find another input. So I started to look at another kind of camera, similar to Kinect, but much, much better. And that's basically a motion capture camera. Those are often very expensive, but I found one that was about 20,000 Swedish kroners. And compared to the Kinect camera, which has like 50 milliseconds of latency, this promised 4 milliseconds. So I was down and actually tried to reduce the amount of time that she would get these signals. And it worked pretty good. So I used these markers that you use for motion capture bodies. And here you can just see an example. I'm just moving this in front of the camera. And basically the screen has a very fast response time. But also, this camera actually shows a lot of reflections. So I started to take this reflective marker and actually replace it with an active infrared light. And then there was even less data for this camera to process. So I got my really fast input. And then what was the actuator and the output? Well, this was one of the tests. We had the camera that would actually sense the conductor with one hand. And a constructor, Rune Andersson, was taking in, and he thought, like, maybe we could actually use the foot instead. I haven't thought of that. The foot actually is really sensitive as well. So he started to build something that I could actually control. So I sent the signals X and Y from the camera down to the motors here. And I really hoped that I could show all the technology here in the box today, but it's patent pending on this. I would love for it to be open source. But this will be, or it has been documented and will be shown on TV, so you will be able to follow the whole process. And basically, we succeeded and actually got her to feel the movements of the conductor. And trying out all these different actuators. And along the way, I realized that many of these can be used for other things where timing is not of essence. For instance, in sports for blind people, or in other professions where you need to have some other kind of input. So I'm going to leave you with that. And you can follow the process, and we will post stuff on this link. And you can also see a trailer of the documentary that will be shown. So, yeah, that was it. Do you have any questions?
Yeah, what's in that box?
Silent noise from here. But I can say 2 motors, that's it. Yes? How do you mean? Yeah, I actually forgot to say that. I used a sensor board with gyroscope and accelerometer and combined them as well. But the thing is, I mean, with these sensors, they have the nature of drifting over time, and even over like 5 minutes, it was really off. And that was the other thing, that the conductor, the reference to the room was really important. Otherwise, that would have been great, I think. Mm-hmm. Ah, yeah, yeah. Mm. Yeah, I think that's also that I could use like temperature, heat and cold, and move things up and down. I think that's also something that could be used for other applications. But here the timing is of essence. So it was 4 milliseconds in the camera, and then about 4 to 10 in the motors. In total, like around 10 to 14. And we wanted to be around under 20 because it was so critical. Yes?
Apparently they're working with a sort of radar that's actually built into a chip that's much higher frequency and less lag.
Ah, yeah, the Google radar sensor.
I'll repeat the question. I can give you the
Great. Thank you.
Thank you, Alan.